Assalamualaikum. My name is Binti Zailani, magic number AM190218. Today I would like to present my bachelor degree project entitled Material Selection of Linear-Low Density Polyethylene LLDPE material for the application of geotube structure, which is supervised by Dr. Muhammad Aimullah bin Abdullah. In this presentation, I would like to explain the detail of my project, which is the introduction, literature review, methodology, expected result, and lastly is the conclusion. So firstly, we will go through the first chapter, which is the introduction. First and foremost, I will present about the background of study. This research will focus on the geotube, which is funded by my Flexi Tank Industry Senior Berhad. This research will be conducted under litigation industrial guideline code M039 in order to evaluate the geotube structure potential in measuring cost setting. Geotube structure, which is a low-cost and basic geobag used for sludge dewatering operation. This geotube has been used for shoreline protection, land reclamation, and offshore structures. In this project, it is required to come up with few suggestions of suitable material to be applied as the geotube structure, including the current used linear-low density polyethylene. So first, we move on to the problem statement. So the first problem statement is my Flexi Tank Industry Senior Berhad suggests a new geotube material to be applied, which is the linear-low density polyethylene to be used as a geotube material. Secondly, is the product of the current LLDPE becomes brittle under UV after some period of time due to its low UV resistance mechanical properties. And lastly, is the material cannot withstand a great friction along the shoreline surface, the sand, and its internal sludge. There are few objectives of this study. First one is to fabricate a geobag for permeability test for different type of LLDPE material. Secondly is to conduct a tensile test for different types of LLDPE material and to observe the differentiation of the mechanical properties. Thirdly is to perform a permeability test for different types of LLDPE geobag. And lastly is to propose suitable LLDPE material for the material used for the application of geotube structuring. To achieve the objective of the study, there is a scope of work that must be taken into consideration. Firstly is the most suitable material of LLDPE for the geotube structure will be identified. Secondly is the mechanical properties of each material options are compared and contrasted by referring to its datasheet of the local LLDPE suppliers. Thirdly is the material will be experimented to test its water permeability, UV resistance, and its compression resistance to find the best material for the non-dewatering technology of the geotube, which can be used for a long period of time. Next, we go through the next chapter, which is the literature review. Geotube containers are comprised of a high-strength, densely woven polypropylene fabric that serves as both a container and a filter. A geotube is a big, porous, weather-resistant geotextile that is specially designed to survive climate change because it will be used outdoors for an extended length of time. The technology of geotube has been widely developed throughout the years since it is regarded as a low-cost product compared to previous existing coastal protection barriers. These are the few advantages for the geotube technology. Firstly, it is a low cost to be compared with the construction cost. The cost for construction of breakwaters and shock protection barriers increases for the raw material and the labor costs. Secondly, the geotube is highly efficient compared to the existing method of barriers construction due to its easy to handle, install, and the ability to discard sludge. Lastly, the geotube technology is very environmental friendly since the material used in the geotubes are only sludge, which is a mixture of biodegradable waste such as wood, sand, and leaves. Geotube dewatering system involves a three-step process, which consists of filling, dewatering, and consolidation. Dewatering is a process of extracting water from solid materials such as sludge or slurry, as well as the removal of leftover liquid as a part of an industrial process. In this geotube dewatering method, the materials used for the geotextile tubes are often have high permeability properties. The first stage of the geotube dewatering method is the filling stage. Geotube containers are filled with dredged material scooped from beds of coastline, shoreline areas, rivers, and even ponds during the filling stage. The dewatering process follows the filling process in the geotube dewatering method. Clear effluent water is simultaneously drained out of the geotextile containers through its fine pores as the dredging materials are filled. The geotube's volume are lowered, and the solid filtrates are successfully contained inside. Solid filtrate confined in geotubes will reach the final stage of the geotube dewatering method, which is the consolidation process, at the end of the final cycle of filling and dewatering. The action or process of making something stronger or more solid is known as consolidation. As a result, geotube becomes solid and strong, allowing it to bear external pressure in the applications such as coastline protection, erosion control, and sludge filtering in agricultural areas. Geotube technology that are invented and introduced in 1962 that is applied as the artificial shoreline protection, breakwaters, and dredge waste material are known only to use the dewatering method. Since the dewatering method is considered as time-consuming and have a high tendency to rupture during its application, the non-dewatering method is introduced to allow a higher efficiency of its application. To accommodate the non-dewatering concept, a low permeability material is required to prevent the water from entering through the geotubes. As a result, the non-dewatering method geotubes is used in conjunction with the plastic film, which is the linear-low density polyethylene. Linear-low density polyethylene is a type of low-cost polymers that is broadly used and have good mechanical and chemical properties. Physically, LLDPE is a semi-rigid and translucent multicolored material which can be easily processed by most methods from granules, shapes to any types of manufacturing usage. So next we go through the next chapter, which is the methodology. So this is my process flowchart. This project starts at the problem identification and followed by the selection of material. Next is to fabricate the sample size of geotube structure to achieve Objective 1. Objective 2 and 3 can be achieved by conducting tensile tests and water permeability tests. Next is the Objective 4, where it consists of the analysis of the result, and finally propose the suitable material before going to the conclusion. In this experiment, 3 samples of LLDPE plastic from different manufacturers with different mechanical properties will be used to compare which LLDPE material has the highest suitability and durability. So these are the list of apparatus and equipments that will be used for the tensile test and the water permeability test. Firstly is the universal testing machine. Secondly is the step sealing machine. Thirdly is the measuring beaker, and lastly is the weighing scale. Tensile strength of a material is defined as the highest amount of stress that it can withstand when being pulled or stretched without failing. There are several types of tensile strength, including the yield strength, ultimate strength, and the breaking strength, each of which can be found in different materials. In this test, I will be using the STM D882 standards as the plastic sheet is less than 1.0 mm. The sample size I will be using is 1 inch times 6 inch. So next is the water permeability test. The physical characteristic of how easily fluid pass through a substance can be ascertained using the permeability test. Air and water can travel through the porous materials that have pores or voids. The purpose of this test is to determine the rate of absorption of water vapor on material. The sample size that we will be using is the 25 cm times 25 cm. The method that we will be used is heat sealing, drying out under sunlight. During the water permeability test, the samples are filled with 250 ml water and is sealed tightly by using a step sealing machine to avoid water spillage. The samples are dried out under sun for days or weeks to record its weight changes. Next is the result and discussion. It is expected to have the final selection of LLDPE material to be applied as the geotube structure based on the analysis of results from both tensile test and the permeability test. First, throughout the tensile test, one of the three ASTM D882 samples will have the highest tensile strength based on the data of elongation and with maximum force of material, their resistance and the strength upon the application of maximum force on the universal testing machine. Hence, as a result, LLDPE material with the highest tensile value will be chosen and proposed as the geotube structure. Secondly, another group of water permeability test sample will be tested by drying it out under the sun for a few days. The properties of these three samples will have different data where it will be low permeability, medium permeability, and the highest permeability. Based on the result that will be obtained in the water permeability test, the LLDPE sample with the lowest permeability test will be chosen since the water will not easily pass through the plastic material to satisfy the non-dewatering concept of geotube application. So, as a conclusion, the evaluation of materials quality is critical for testing its quality and determining whether it is fit or not for using it in real-life application. The tensile test is used to measure the maximum amount of stress that a material can bear without failing when pulled or stretched. Water permeability testing, on the other hand, is used to measure the ability and rate at which water can travel through the sealed material. To assure the quality and productivity of the geotube in the future, it is best to analyze and discuss the material attributes at the conclusion of this study. So that's all from me. Thank you.